It's still not over, so there's another problem that we have to talk about. Because you have boundaries on both sides of your channel. Okay, so you have a channel that you split up into grid cells, and the channel starts somewhere. So we have something that I call k equals 0, is your first point. And something that I decide to call nx plus 1 is the last point. Okay? And these extra points, okay, I get so many emails, as you can see. Let me just dismiss this. So these extra points that you need are actually called boundaries or ghost cells. Okay? They are used to specify boundary conditions. So boundary conditions, for example, what you could do is you could assume closed boundaries, we call them. Closed boundaries is by setting the horizontal velocity to 0. Okay, these are called no-flow conditions. This is what you could use. If you use a 0 boundary conditions, means that the velocity is always 0, okay, and it has a certain implication. What you also could use, what sometimes is used, is called zero gradient conditions, which means that the value in the ghost cell is the same as the one in the adjacent grid cell, zero gradient. Or what you could do is use cyclic boundary connections, which means that both sides are connected. Okay, and a way to do it is if you have a band and you fold it and flip it over and overlap and connect these both sides, and that's what's written behind me. That's how you do it. Okay, so what leaves, if there's a way leaving on the right hand side, comes in back on the left side, the other way. So that's lateral boundary conditions. But there's another problem is, well, how do you actually specify coasts? And land or coasts. And we talk about that on the next slide.